Hello, everyone. My name is Robert Haas. I work as VP Chief Architect Database Servers at EDB, where I've been since 2010, which is a really long time. And I'm also a PostgreSQL major contributor and committer. And my talk today is about PG plan advice. So what might you ask is PG plan advice? Well, at the broadest level, it is a new contrib module that is, as of the last time I checked, still committed for hopeful release in PostgreSQL 19. In terms of what it does, PG plan advice implements a mini language that can be used to describe key planner decisions. A really important part of the design here is that PG plan advice both generates and accepts this mini language. So the idea is that when a query is planned, you can ask the system to tell you what decisions were made, and you'll get the answer back in the form of a string. And then by providing that string back at a later point in time, you can ask the system to make those same decisions again. Or you could edit the string, and then you would be asking the system to make different decisions the next time, or possibly you would have created a syntax error, depending on how good your editing is. So the first question that you might be thinking about isn't this just planner hints? And I think the answer to that question, other people are probably going to think different things, but I think the answer to that question is both yes and no, right? You can absolutely use plan advice the way that people use hints in other database systems, but my real goal here was to create a plan stability feature. I wanted to have a way that if you have a plan for a critical query on your production system, and you're worried that maybe that plan is going to change at an inopportune moment, you could ask the system to please not do that. But of course, if I provide a control language that allows you to ask the system to keep doing the same thing, you could choose to use that same system to ask it to do a different thing. I personally think that's okay. I don't know how useful that technique is going to be, and obviously there's a bunch of risk involved, because if you ask it to do something really bad, then terrible things are going to happen to you and possibly your production system. But it's certainly a useful alternative to have in the case of emergency, and I think probably even more importantly, I found that it's great for development and testing, because I have discovered all kinds of weird planner behaviors that I suspect nobody really had any idea about in the process of developing this feature. And those are very hard to discover if you have to manufacture the plan that you want by getting the statistics just right and the query just right and all of those kinds of things. Now, a second point that I want to make before I really get going is that I'm not the first person to do work in this area, and I want to acknowledge that. There are multiple out-of-core extensions that exist for both hints and for plan stability. And I don't want to dismiss any of those things, but I'm also not an expert on them. So this talk is mostly not going to be a comparison of what I've done here with previous systems. It's going to focus on what this does. I do think that I've taken an approach that is a bit different from anything that I know of someone having done in the past, because as far as I know, the existing systems are either pure hinting systems where there's no intention of trying to do anything with plan stability, or else they do things like try to save and restore complete plans, which I feel is a problematic concept for various reasons that I'm not going to try to detail right at this moment. And this system that I've built here kind of integrates those two ideas together in one system. So I think I've done something at least a little bit new, but I could be wrong, because as I say, I'm not an expert on what everyone else has done, and I don't mean to make light of all the people who have put work into this area. What I do want to do with the talk is sort of talk through the major engineering challenges that I have attempted to overcome in doing this project. First of all, with respect to advice language design, What planner decisions do we want to try to control? What's out of scope? What should the syntax look like? Those kinds of questions. Then I want to talk a little bit about some somewhat surprising, I would say, problems that I ran into with the generating advice part of this solution. Having the planner tell you what it decided turned out to be a little bit more complicated than I thought that it was going to be. And then I want to talk about problems related to advice enforcement, making the planner do a particular thing. Underlying that, a concern that I had throughout this project was that if I changed too much planner code or introduced too many concepts with which existing hackers are unfamiliar, they're going to be even more mad about me attempting to do this project. And so I really wanted to avoid that. That's not a separate section of the talk, but you'll see that running through some of the things that I'm talking about here. So let's talk about the design of the advice language. I'm first going to show you a simple example so you can get the flavor of it, and then we'll talk about some of the things that go into the whole picture. So what I've done here, this example is taken from PGPlanAdvice's regression tests, is I've run a query, and I first loaded the PGPlanAdvice config module. And by loading that config module, explain gets a plan advice option that it wouldn't otherwise support. And I've used that option here. And so in addition to printing out the plan, I also have this section at the bottom that says generated plan advice. What's shown here on the slide is actually formatted slightly differently in terms of white space from the way that it would be printed. And that's just to make it fit on the slide better. And what I hope you can see here is that the generated plan advice is a textual description of what the plan does, or at least some of what the plan does. It says what the join order is, that the driving table in this plan is F, and it gets then joined to D. When that happens, a hash join is used. We access both table F and table D using a sequential scan. And it also says that this plan contains a gather and merge node, which appears just above the join between F and D. There are other things that are not described here. So some of you might know that the planner could create a plan which we would be able to execute, where instead of a parallel hash operation, we just had a hash operation, and then instead of the scan on D being a parallel sequential scan, we would just have a sequential scan. That's also a legal plan for this query, and all of this generated advice would be exactly the same if we had that plan as with this plan here. Similarly, things like the hash condition or the number of parallel workers, the sort key of the gather merge, none of that stuff is captured. So this is a kind of a sketch of the most important decisions that were made while generating the plan. Now you might ask, most important according to who? Well, according to me, obviously, because I'm the one who designed this system. And it's very possible you may not agree, and then we'll have to talk about what we should do about that. But hopefully I've got it mostly right. So how did I come up with this syntax? Well, there were a variety of existing hinting systems that write an operator name and then a list of targets for that operator name in parentheses. And I decided to start with that syntax because I think it's probably familiar to a lot of people who have used other hinting systems. PG hint plan is the most relevant precedent in the PostgreSQL space. Obviously, many of you will be aware of precedents in other spaces. We're not going to talk about that here. So I started with that syntax, but that syntax, at least as I've seen it implemented in other systems, is not unambiguous and round-trip safe, which it needs to be if this is to be a plan stability system. We need to be able to describe what decisions were made in any plan that anybody wrote, no matter how hard they were trying to write that plan in a way that would create problems for PGPlanAdvice. They should not succeed. We should always be able to capture the key decisions and ask for those decisions to be recreated. And basically, one of the big problems here is that these relation aliases that we're using to refer to particular tables in the query are not guaranteed to be unique. In simple cases, they are required to be unique. For example, if you just say select star from x comma x, you will get an error, and the system will tell you that table name x cannot be specified more than once, and you would have to alias one of those copies of x to something else, and then you wouldn't have duplication anymore. But there are 3 different ways that you can work around this. The first one, as shown in the second query on this slide, is to just use a subquery. I've got select star from x, where exists, open parentheses, select star from x, close parentheses, and that query is accepted. Because the x that's inside the subquery, well, the x that's outside the subquery doesn't see the x that's inside the subquery, and the parser is okay with this. It thinks this is fine. So, and it is fine from the point of view of actually knowing what this query means, but if I need to be able to describe what happens with the inner x, and then I also need to be able to describe what happens with the outer x, I'm going to have some way of telling those 2 things apart. You can also create ambiguity without using subqueries. You just have to be a little bit more clever in what you try to do. So in the first example on the slide that fails, I literally just say x comma x. But if I join x to something, in this case just a values clause, and then I alias the result to y, I can now join that back to x, and once again the parser doesn't complain. And here it's really well justified that the parser doesn't complain, because the fact that that y is present in the query means that all of the columns that come out of the parenthesized thing get renamed to y for purposes of everything outside that level. So at the topmost level of this from clause, we have y and x, and they're 2 completely separate things. And then within the set of parentheses, we have x, and then whatever column labels are automatically assigned for the values clause. So there is no ambiguity here from the point of view of somebody writing the query, but we still don't have a way of saying which x it is that we're actually talking about. The good thing about this kind of thing here is that people don't usually do it, because it's really confusing to actually write your queries like this. But you can do it, and again, I was looking for something that couldn't just be foiled by the user deciding to write their query in a funny way, but that was actually really going to work. And then the sort of third way that this can happen is x could be a partition table, and if that's the case, then the query never needs to talk about each partition individually, but plan advice does need to talk about the partitions individually, because they're going to be planned separately. So we've sort of got 3 cases here. We've got subqueries, that's one case. Then we've got weird cases where you do it within the same subquery level by using aliasing tricks. And then we've got partition tables. So how are we going to sort out all this ambiguity? Well, I just made a syntax that had a provision for each of those 3 cases. So the general syntax for what I'm calling a relation identifier is the alias, and then a number sign followed by the occurrence number, and then a slash, and then partition schema.partition name, and then an @ sign, and the plan name. But you just leave out the components that you don't need in any particular case, and the punctuation that immediately precedes them. So using the same table alias multiple times in the same subquery level is something that almost nobody is going to do. And so almost all of the time the occurrence number will be 1, and we don't need to write number 1, because we can just make that the default. So that very rarely gets used. The partition schema and partition name do get used quite a bit, because lots of queries involve partitioning in some way. And then the @plan name at the end, that also gets used a fair amount, because many times you do have some subqueries. So the advantage of this from my point of view is that the relation identifiers stay really simple in simple cases, like in the example I showed you to start out with, where the relation identifiers were F and D. They were 1-character identifiers, and they're completely unambiguous. We know exactly what we're talking about. But when we need to be really precise and refer to something in a complicated query, the full expressive power is there, and we can describe something like there should be a sequential scan on the third copy of the orders table, specifically the partition called public.orders2026, all of which is inside the subquery that's called expr1. This does not fully sort out the problem of having something that is round-trip safe. It does give us an unambiguous way of referring to a particular table that is going to be accessed by a particular query, but identifying individual tables is not the only problem that we have. Sometimes we need to identify groups of tables. This slide is an example of that. So what is the join order here? Well, we start with apple, that's the driving table, and we first join it to banana, then we join it to carrot, then we join it to daikon, then we join it to eggplant. Well, and the next table in the explain output is fennel, but we're not joining the result of our 5-way join directly to fennel. Fennel is first being joined to garlic, and then the result of that is being put into the main join order, so to speak. So we need a way of distinguishing this case where fennel and garlic are joined to each other first from the more straightforward case where we just join all of the tables one at a time. And the way that I chose to disambiguate that was to just use an extra layer of parentheses. So the join order for this query is as shown over here, apple, banana, carrot, daikon, eggplant, and then in parentheses, fennel and garlic. And the same problem arises when we're trying to describe the join methods that were used. So a decision that I made that some people may think is wrong, but I'm fairly convinced is right, is that the way that we describe the join method is we say the second thing that was an input to that join. So in this case, for example, the inner merge join has apple and banana on the outer side. The first input to the join is the join between apple and banana. And the second input to that merge join is the carrot table. So we describe that by saying merge join plain on carrot. We ignore the first input. We say what the second input was. At that point, when we joined the carrot table in, we used a plain merge join. Now, the fennel garlic problem comes right back here. The second input to the outer merge join that's at the top level of the plan is not a single table, it is a group of 2 tables. And I solved that problem in the same way, just put an extra layer of parentheses around it, and now we know exactly what we're talking about. There are other aspects of the advice language design that I could go into here, but I think those are the most interesting points, and we just don't have a huge amount of time, so I'm going to, in each section of this talk, just focus on the highlights and then move on. So if you want a full overview of the advice language, there is documentation for it, but that is as much as I'm going to say about it here, because I think those were by far the most interesting design problems that I encountered. So now I'm going to talk about advice generation, and it was a surprise to me that this ended up being as tricky as it was, because I had the intuition that if you just look at the final plan, you should be able to figure out what the planner did. How many people share that intuition? Some. Not as many as I would have thought. Basically, that's true if you're experienced in reading explain output, at least. But there were various corner cases where the final plan was ambiguous. And for this to work, again, in all cases, those had to be fixed. So here's the easiest to understand example, which some of you may find not easy to understand, for which I apologize. But what I've got here is a query with 3 tables, T1, T2, and T3. And both of the joins are left joins, and both of the join clauses are on false. So what that means is we're going to scan the T1 table, and we're supposedly joining it to T2, but because the join clause is on false, we're never going to actually match a row in T2. And because it's a left join, we'll still emit the rows from T1, they'll just be null extended. And then we will join to T3, where the situation is the same. We will, again, null extend the rows based on this join to T3, but false is never true. So we will never actually match a row from T3. So the planner looks at this and it realizes we don't really need to scan T2 and T3 at all. We don't need to pick a sequential scan. We don't need to pick an index scan. We can never actually need a row from T2 or T3. And so it inserts a result node. And result nodes have a couple of different jobs within the PostgreSQL query planner, but one of those jobs is returning nothing when we need a plan node that can just not return anything. And that's what it's doing here. But in previous releases, result nodes were not labeled anyway, so you couldn't tell what the source of any particular result node was, which was a problem for PGPlanAdvice, because if it wants to say what the join order is, it says, okay, T1 gets joined to some result node that we can't tell whether it was T2 or T3, and then it gets joined to the other result node, which must be the remaining one, but we couldn't tell which was which, so we couldn't actually describe the join order that had been chosen. So what we did is now in explain output, you see these replace this lines that are generated from some underlying data stored in the C data structure, and they tell you what the origin of that particular result node was. And so that allows us to generate a join order for this plan, which is T1, T2, T3, and it also allows us to correctly describe the join methods, which in this case are just plain nested loops. So that fix was this first commit that I have here on this slide. Keep track of what RTIs a result node is scanning. And that's how I solved the problem that I just talked to you about. I don't want to spend too much time going through the whole slide here because it has a lot of text, and this is all a bit dull and all a bit confusing. But there were several problems of this type. You know, how many people looking at explain output have seen subquery scan show up? And how many people have used a subquery and not seen subquery scan show up? Quite a few. It often doesn't, because the query planner just strips that subquery scan out of there, because it says at runtime this subquery scan is not going to do anything useful, and so we don't need to actually run it, which is completely true. But if I'm trying to analyze the plan and figure out which part came from the outer query and which part came from the subquery scan node acts like a boundary that separates those things. And when you remove that boundary because you don't need to do anything at execution time, I can get confused and not understand which part of the query came from where, which then makes this all not work. And a similar kind of thing can happen with append and merge append nodes, because if, for example, a partition table only has one child, or it only has one child that survives the pruning process, we say, well, we don't actually need an append node because we're only appending one thing, so we can just throw the append node away and scan the underlying thing. Once again, totally makes sense from the point of view of making the plan execute quickly, but it's very awkward from the point of view of trying to analyze the plan and understand what has happened. It's possible that I could have somehow solved these problems in ways that didn't require any changes, but I couldn't figure out a way. I'm not sure that there is a way. So what I did to solve some of these problems is basically just added very small amounts of information to the final plan that are not needed by the executor and are stored in a part of the plan where the executor can just ignore them. So the plan gets very slightly bigger in terms of the amount of memory that it's consuming, but it doesn't run any slower because the annotations that I'm storing here are sort of shoved off in the corner where everything that's not PGPlanAdvice or a similar contrib module written by someone else can just pay no attention to that stuff. So those problems were about information being available during the planning process, and then that information sort of disappears by the time planning is complete, with the result that we can't exactly tell what the planner did. I also ran into some problems, one problem in particular that was kind of the other way around. The information was available at the end of planning, but it wasn't available as we were making the planner decisions that we want to control. And this created a problem in the opposite direction. It was totally fine when you were trying to generate advice, because you could say, at this point in the plan, we made this decision. But then when you later tried to use that advice for something, the question is, well, the user said that when we planned this thing, we did it this way, and we want to do that again. Are we at that point? Well, we don't know, right? Because we haven't made all of the necessary decisions yet to know where we actually are in the planning process. So we don't know whether the part of the query that we're planning right now corresponds to this particular part of the plan advice string. And so we can't decide whether or not we should be trying to control the outcome of the planning process. This basically had to do with, this mostly I think had to do with, well, one of the big problems here was that subqueries were only given a name after we had completely finished planning the subquery. And that really doesn't work for something like this, because then as you're planning the subquery, you don't yet know what it's named, so you don't know whether your plan advice applies to it. So anyway, these commits that I've mentioned here were oriented towards fixing that problem. And that brings me to the topic of advice enforcement, which means making the planner do what we asked it very nicely if it would please do. And there are a couple of problems here. One of them is very simply, where do we get the plan advice string that we're supposed to use? I mean, it's not part of the query. It has to get into this system in some other way in order for us to be able to do anything with it. So I implemented a couple of different methods for dealing with that problem. The first one I implemented is the simplest thing that you can really imagine in a PostgreSQL context, which is you just set a variable, right? You set a parameter. You say set pgplanadvice.advice equals, you put your advice string in there, and boom, in it goes. This works. It's a bit clunky, because you're executing an extra query to provide the advice string, and immediately after you then plan the query, you're going to need to probably reset this variable back to empty, so you don't keep using the plan advice for other queries to which it shouldn't apply. Or maybe you're going to use plan advice for lots of queries, and then you're just going to keep set this variable, run a query, set this variable, run a query, set this variable, run a query, boom, boom, boom. Works, usable for some things, awkward for sure. So the second method that I implemented is a separate contrib module called PGStashAdvice, which is also currently committed to PostgreSQL 19, and we'll see if that survives contact with the enemy. And what that does is automated matching by query ID. And so the idea here is that you create an in-memory object called an advice stash, and you give it a name. Here I've very creatively used my stash as the name. And then what that advice stash is basically just a mapping from query IDs to advice strings. So you say, okay, I want to map query ID 1, 2, 3, 4, 5, 6, 7, 8, 9 to some advice string. And now you've got this stash, and this stash contains this mapping. And so the last step is you need to point the system at that stash and say, this stash is the one that I actually want to use. Here, I've done that by using an interactive set command. So I've just said, set pgstashadvice.stashname equals my stash. But you could put this in PostgreSQL.conf. You run alter database set. You could run alter role set to just apply this to your application user. So this is another way of doing it. It's also a bit clunky and limited. I think it's absolutely a bit clunky and a bit limited. The nice thing about it is possible to deploy this method with 0 application changes, right? You can fire up a session. You can make your stashes. You can map your query IDs onto strings. And then you can use alter role set or alter database set or PostgreSQL.conf or alter system set, any method you like, in order to get the stash name set for all of the sessions that you care about to the value that you want them to have, and boom, suddenly you've got advice strings applying to queries. But a limitation of this method is that it assumes that you can figure out the query ID and that you always want to use the same advice string for the same query ID, which could be false. There's probably other disadvantages to this method as well that I don't really have on the tip of my tongue, but this is V1 technology, and I'm sure that there are some things here that are not fully ironed out, and this probably isn't going to work perfectly for everybody in all situations. So the other thing I did is I made this pluggable. PG Plan Advice is a loadable module, but it can talk to other loadable modules. So you can call up PG Plan Advice and say, hey, I'm an advisor. Here's my advisor function. And PG Plan Advice will say, sure, okay. Every time a query is planned, I'm going to call your advisor function. If you return an advice string, then I will attempt to use that to guide the planning of that query. And if you don't return an advice string, you don't want to return an advice string, you can just return null, and then I'll ignore you for purposes of this query, and you can try again for the next one if you'd like to do that. And I think that's pretty cool. Like, there's already a test module that uses this, which I think is cool. I have some other ideas that I'll mention briefly at the end about how this can be used, but I do think there's the potential for experimentation here. I'm trying to create a little bit of separation of mechanism and policy. PG Plan Advice is giving you a way to control planner decisions using advice strings, but it's not trying to dictate where those advice strings come from or whether you store them or generate them on the fly or how you get them. So there's maybe an opportunity for some innovation there. Now, that brings us to the question of, okay, so we've got the advice string somehow. How do we actually enforce the advice? Our strategy here is going to be run the planner in the normal way, because it does all kinds of really complicated things that are super important, and we don't want to duplicate all of that code. But we're going to arrange to disable any paths that are incompatible with the supplied advice. And so any surviving paths should comply with the advice, and the user will therefore get what they're asking for and hopefully be happy. But there are two problems. First of all, in previous releases, we could only disable paths for the entire plan. You could say, set enable hash join equals false, and then that would disable every hash join plan for the entire planning process. But that's obviously not what we need for this project. Also, before PostgreSQL 18, disabling a path, only 99.2% disabled it. Because what we actually did is just made that path look really expensive, which is a good way of getting the planner to not pick something, because it likes to pick things that are cheap. That's its whole job. But it's possible that some non-disabled path looked even more expensive than that gigantic number that we used for the cost of a disabled path. And then the fact that it was disabled would be ignored and it would get picked anyway. So starting in PostgreSQL 18, we first compare whether paths are disabled, and if that's a tie, then and only then do we look at the cost. So that hopefully closes up that other 0.8%. Now, it is possible to write plan advice strings that ask for impossible things. And if you do that, you will potentially disable every single path that could ever exist. Some cases, PG Plan Advice will detect, and it can tell you, hey, you can't have it both ways. But it's possible to construct cases where it can't detect that you're asking for something that can't be done, and then you'll just succeed in disabling every possible path, and query planning will still succeed, and you will get some disabled plan for your query, and it will probably be terrible and run for an incredibly long time, and you'll probably be really sad that you worked so hard to create a plan advice string that doesn't actually do anything useful except destroy the system. So maybe don't do that, but it doesn't cause a hard failure. It just causes the plan to be probably really bad. So in terms of how do we actually allow paths to be disabled on a fine-grained basis, the concept that I came up with was a new bit mask called PGS mask for path generation strategy mask, and this now appears as arguments to various C functions inside the planner and inside various data structures that the planner uses, and it can be set on multiple levels. You can set it for the whole plan, you can set it for a particular base relation, a particular join, or even more fine-grained than an entire join, you can set it for a particular method of building up a particular join. And this mechanism is now used internally to implement the same settings that we've already had. If you say enable nest loop equals false, then it clears a couple of bits in this PGS mask for the entirety of the planning process, and it disables nested loops in exactly the same way that it always did. But an extension like PGPlanAdvice or one that you write can flip those bits on and off in some other way and therefore achieve fine-grained control over what the planner does. What I think is really interesting about this mechanism is that I found that it works extremely well, but it's not easy to make it work well. It took a lot of code in order to actually use this mechanism to do what I wanted to do, which I think is kind of good because it means that a lot of the complexity is in the contrib module, which most people can ignore most of the time, even if they're hacking on the planner, and only a relatively small amount of the complexity is actually in the core optimizer, just sort of changing the way that we implement enable SEQ scan and so forth. So here's an example. Let's suppose the user says that they want a gather node positioned in the plan above the join between foo and bar. Well, what do we need to do to enforce this? To be clear, in PGPlanAdvice's mini language, this means that the gather node should appear immediately above the join between foo and bar with nothing other than foo and bar underneath it. That's what this is intended to mean. So what do we need to prohibit in order to make sure that's the outcome that we end up with? Well, several things, as it turns out. When we're planning the join that has exactly foo and bar underneath it, we need to disallow all alternatives other than a gather node. So that means we need to disable gather merge, and we also need to disable any sort of non-parallel plan and keep that from winning there, because if a non-parallel plan won, then the gather would not. But we also need to constrain the planning of any set of relations that is not exactly foo and bar, but contains either of them. Because if any of those relations are allowed to produce a gather node or a gather merge node that is not disabled, then that might be the winning alternative, and the join between foo and bar might never appear in the plan at all, or it might appear at a point where a gather has already been done, and we can't stack one gather node on top of another, so we then won't be able to produce the thing that the advice is asking us to do. And we also need to constrain the join order. If we join either table foo or bar to some third table before we join them to each other, then we are going to fail to put a gather node on top of exactly foo and bar, because there will be no place in the plan where that can possibly happen. The only way to have a gather node that has just foo and bar under it is if they're joined to each other first before they're joined to any other thing. So we've also got to rule those out. So this seemingly simple directive from a user point of view, put the gather node here, actually turns into this somewhat complicated three-part enforcement strategy where we run around and find all of the things that don't result in that outcome. I spent an enormous amount of time trying to get these rules right for all of the things that PGPlanAdvice knows how to do. It was really hard, and it was only because I had the test PlanAdvice module as a testing module available that I think I've eventually got the rules correct, so that when you ask for something, we will disallow the right things in order to make sure that it really happens. The planner, as I've discovered, loves to avoid doing what I thought I was asking it for by doing something that technically complies with what I told it to do, but isn't actually what I wanted. And that makes sense if you think about it, because the planner's job is to find the cheapest cost plan. And so if I say, hey, when you do X, please do it in way Y, the planner's response is, well, maybe I can just avoid doing X in the first place, and then your instructions will not affect me. Bwah, ha, 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 ha. So a lot of, as I say, a lot of code here went into making sure that that didn't happen, that we didn't block too much and that we didn't block too little, but that we blocked exactly the right amount of stuff so that when you write a positive constraint that says this must be done in this way, that gets turned into exactly the right set of negative constraints to disable the things that would prevent that from happening. ScanAdvice actually doesn't really have this problem. I mean, there's a few cases to deal with, but if you want a sequential scan on a particular table, if you disable everything but sequential scan on that table, there's kind of no way for the planner to work around that in most cases. But as soon as you get past the scan level, it gets pretty complicated. And it turns out that at least for what PGPlan advice currently covers, almost every tag involves some kind of implicit negative join order constraint. That if you want to make sure this happens, we must not allow join orders that would cause it to not occur. And that brings me to potential future work. I think one of the things, people say a lot of things about hints when it comes to PostgreSQL, and some of those things are more positive than others. But one thing that people say is that a hint that describes an outcome is a bad idea, and what you should actually be doing is fixing the row count estimate so that the planner organically comes up with the right plan. Now, I didn't do that for the very simple reason that, again, the goal here was to create a plan stability feature, and a plan stability feature means actually doing the same thing that we were doing before. But I do think that having some control over cardinality, some way of saying, hey, I know you're going to get this row count estimate wrong, here's what it should be, is probably a good extension to this work. Another area is this doesn't currently control anything about how we choose to do aggregation. There are other parts of planning that it doesn't try to control, number of parallel workers, all sorts of things. So it could be extended to control more stuff than it currently does. And then the third area that I think is really interesting is experimenting with the advisor hook interface that I mentioned before. Like one thing we could do is we could just generate like basically random advice strings for a query and just force the same query on the same data to run in all different kinds of ways. And we could see, do all of those plans succeed without error? Do they all produce the same results? Like we have a lot of tests for our planner, but they can't do this kind of testing. They test that, they constrain things so that we always get the same plan, and the regression test run, and we know that that plan for that query produces the right results, but that doesn't mean that every possible plan for that query produces the right results. So that could be used for testing. It could also potentially be used to search for defects in our cost model, because we could generate various different plans for the same query on the same data and then see if any of them seem like they run faster than the one that the query planner thinks is cheapest, and we could use that for research purposes to improve the system. Another sort of thing to think about is that everything I've just described is super manual. It assumes that there is a smart DBA who is going to look at all of this and make amazing decisions about when it is a good idea to do any of this stuff, and there might not be a smart DBA, or they might be busy. So I expect that somebody is probably going to experiment with some automatic systems that try to figure out when it might be a good idea to use plan advice and experiment with that. And the advisor hook should be very useful for that kind of thing. Combining that idea with the first idea of cardinality hints, you could try to take information about cardinality that you learn from one execution of the query and then use this system to feed it back into future systems, similar to what PGPlan Advisor, an existing module that I just found out about relatively recently, or another one called AQO. They already do this, but they don't have the concept of an advice language as a sort of way of passing the data through. They use other mechanisms for propagating that information forward from one cycle to the next. And I think they might benefit from sort of being incorporated into this framework, but we'll see. This is all future research. So thank you for coming to my talk. And now I can take a question or two.
So we have 5 minutes for questions. Please go.
Okay, so you had mentioned earlier that it seems the issue with getting the information to the planner is how to tell it in advance of the command what to do. It is possible to actually put the information on the same command line as a comment, which is carried through the actual parser.
Yeah,
and then you could pull that out, and then so that it could be tailored to those.
Right. So I'm aware that comments are a way that some people think is good to feed this information through from parsing to execution. And I welcome people to experiment in that area. I'm not personally planning to experiment in that area, but I think it's a completely reasonable thing to play around with. And if you arrive at something good, awesome.
If it's a dumb question, if it's just a plan stability is the primary concern, why don't you just take the, plan output and use that original string as invent a new language?
Yeah,
Why don't we?
It's a great question. So we already have a node tree representation that we can use to serialize plans and deserialize them. So you could do that. But the thing that I think is bad about that approach is that it's very easy to create a situation where it's not legal to use the old plan anymore. For example, if you add a column or drop a column, the old plan as it existed is totally invalid. You cannot run that plan anymore. So now you go to, as soon as you do that, you have to get a complete reset and you have no idea what new plan you're going to get. This system, the characteristics, you're asking for the plan to have particular characteristics rather than for the plan to be exactly the same. So
I would argue somebody drop a column and it's anyway reset, right? You should establish a new base. And
I mean, I'm not preventing someone from using a system that works that way, and I know there is out-of-core code that does that. I personally don't think it's a good solution, so that's why I did it this way. But opinions vary on this topic very widely, and you are as entitled to your opinion as I am to mine.
Is there any way to give negative advice, like instead of forcing one planner decision, can you somehow, if there's three choices the planner is able to make, can you tell it?
Don't use a nest loop.
Don't use A, but you may do B and C?
Yeah, currently there's not. Again, because I didn't need that for the plan stability aspect of this, but I did think about that, and I think it might be worth considering adding that in the future. As you might imagine, this was a fairly complicated project, and I didn't want to burden it with a bunch of things that I didn't absolutely need. So that was one of the things that I thought about it. It went straight on the cutting room floor because I didn't 100% need it.
Hello, thank you for the presentation. My question is, how prepared statements get affected by this? Like, let's say if you already have a query that's prepared in the prepared statement, and I add an advice for that query, do we purge the prepared statement and redo it?
So this extension is not capable of changing the timing at which the planner runs. I have already made the mistake of using this with prepared queries and not thinking carefully enough about when the query might be replanned and not having the same plan advice string in effect at every point at which the query could be replanned. And if you do that, weird things happen that are not very fun. Like, it doesn't break, but you just might not get the plan that you're expecting, because whenever the replanning happens, the plan advice is enforced. Let's get Tom's question there. At that point, and so you have to, you just have to be aware that that's how it works. So, yeah. Can we do Tom?
Hello.
Yes, we have order.
Sorry.
So currently there are not many optimizer hooks that can control the plan. So for example, aggregation, parallel queries, memoirs, and so on. So now, given that this is in a contrib module, can we expect more hooks in the optimizer side?
Well, so I did have to add some hooks in order to make all of this work. So there are already a few more hooks than there used to be, and some other infrastructure for extensions. I suspect if this gets extended or added to, or people try to do more things, we'll use more, but I would suggest taking a look, because there is a bunch of new stuff that we didn't used to have.
Yeah, for example, eager aggregation, so we need a separate hook for that, and so on.
Yeah, there's a bunch of things to think about there, yeah, for sure.
Okay. So tying into a couple of questions were just asked, what happens if you supply an advice string that doesn't apply to the query, like it uses aliases don't exist or whatever?
Yeah, there's a whole advice feedback mechanism that I did not have time to talk about, where you can get the planner to tell you, if you run explain on the query, it'll tell you which advice worked and which advice didn't work because of problems like that, right? If you don't look, what happens is that any advice that you supplied that is not applicable to the query just doesn't do anything. But I thought it was really important to actually have that feedback mechanism, because one of the things that I've experienced is that if you have a way of asking for something and you don't have a way of telling that it worked, whether it worked or why it didn't work or something like that, very quickly becomes super confusing. So there's a whole mechanism that I just didn't have time to talk about that helps to address that.
But the shorter answer is you don't get an error.
You don't, this is designed to never make the planner fail. If it does, that's a bug and I need to fix it. It is not designed to keep you from producing plans that run until the heat death of the universe. So if that happens, that's on you.
And let's finish on this positive note. Thanks, Robert.